All right, good morning, guys. Welcome back from spring break. Hopefully, you guys had a much needed rest. We are going to begin Unit 9. Now, I just want to let you know that we have 3 units left this year, which is crazy. I believe after Unit 11, we'll start studying for the final exam. So just keep that in mind. I know it's been a rough year for a lot of people, but we're almost through it. So you guys can do it. Here is our schedule, which you guys have. Today we're going to be talking about vectors, and I'm actually going to break it up into probably 2, possibly 3 videos, just because there's so many different aspects to it and different things that we're going to be doing with vectors. All right, so the first thing that we're going to be doing is finding the component form of a vector and the magnitude as well. All right. So these are the 2 formulas we're going to be using. This is the one for component form, and this is the one for the magnitude. And I'm just going to jump into this example down here. All right, so for example 1, you're going to find the component form and magnitude of the vector v that has the initial point of -2, 3, and the terminal point of -7, 9. Now, the initial point is represented by P1, P2. So I'm actually going to label that. And then the terminal point is going to be Q. I think the lowercase q is just a little confusing. I mean, I'm just going to write it that way, but just try not to get them confused. I know they look kind of similar. Is represented by Q1, Q2. Now, first thing we'll do is find the component form, which is Q1 minus P1. So you're basically taking the x2 minus the x1, the terminal x minus the initial x. All right, so I'm going to go ahead and write. We've got -7 minus P1, which is -2. I'm going to go ahead and put that in a bracket, comma Q2, which is 9, minus P2, which is 3. All right, we're going to simplify this. I think the biggest mistake people are going to make is when you're subtracting a negative, just making sure that that means we are adding a positive. So we have -7 plus 2. That's going to give us a -5. All right, and then we have 9 minus 3, which is 6. All right, so this is your component form. And I'm just going to write that off to the side here. All right, the next thing we're going to do is find the magnitude, which we have to use the component form in order to do. It just makes it that much easier because we've already found that, right? This is the same equation as what we have up here. So what we're going to do is we're actually going to label this V1 and V2, since that is the component form. Once we have that, we will use this bottom one here. We have the square root of V1 squared. So we have a -5 squared plus V2 6 squared. All right, -5 squared is going to be 25 plus 36. And this leaves us with the square root of 61. And we're going to leave it just like that. All right, and that is your magnitude. Okay, and I think this is the only example that we will do finding component form and magnitude. Let us move on to addition and multiplication. I think for the most part, you guys will like the beginning of this unit. All right, so we are given some formulas up here. If we are to add to u and v together, which u is a coordinate, right? It's an x and a y, and then v is an x and a y. Think about it like this. You can only add the x's together, right? 5 and -3, and then 1 and -2 go together. All right, so we can't add them together unless they are in the same coordinate position. Okay, so kind of keep that in mind because that's going to help you as you go. So if you are adding a u and v together, such as this and this one, you add the u1 which is the first one, and the V1, which is the first one for the V. And then you'll also add the Y and the Y together. All right, so we're gonna do an example here. The first one is 2V. All we're doing is taking V, which is 5 comma negative 2, and we're gonna multiply that 5 by 2 and the negative 2 times 2. It still stays looking like a coordinate. All right, that gives us 10 comma negative 4. All right, and that's our answer. All we did was multiply the V1 and V2 coordinates by 2, both of them by 2, and it gives us a new one. All right, let's look at B. We have W minus V. Oh, and I forgot there was a W. So that means we are going to take, and I'll just write it off to the side here, W1 minus V1, comma, W2 minus V2. All right, and that's what it's going to look like once we simplify it. So I'll just write it here. W1, which is 4, minus V1, which is 5, comma, W2, 7, minus negative 2. All right, that becomes adding. So we have 4 minus 5, that gives us negative 1. And then 7 plus 2 gives us 9. All right, moving on to the next one. We have W plus 2U. So what I'm gonna first do is do the 2U, just to make it a little easier. So we have negative 3 comma 1, which I'm going to multiply by 2. So we have negative 3 times 2, and then comma 1 times 2. And our 2U is technically negative 6 comma 2. All right, this represents 2U. Okay, so we are going to add this to W. So we have 4 plus negative 6 comma 7 plus 2. All right, that gives us 4 minus 6, which is negative 2. And if you are really uncomfortable with adding and subtracting negatives, feel free to use a calculator. I would like for you to not have to, but at the end of the day, I do want you to get it correct. And if you struggle to add negatives and subtract negatives, then I would much rather you just double check your work with a calculator. All right, then we have 7 plus 2, which is 9. And that is our answer. All right, we have one more. We have 3U minus V. So again, I'm going to do the 3U first. So we have negative 3 comma 1, which I'm going to multiply by 3. So we have negative 3 times 3 comma 1 times 3. And that gives us negative 9 comma 3. So that is my 3U. So then I will take negative 9 minus V1, which is 5, comma 3 minus V2, negative 2. All right, so negative 9 minus 5 is the same as negative 9 plus negative 5. So we have negative 14, and then 3 minus negative 2 is 3 plus positive 2, which is going to be 5. And that is our answer there. All right, that's where I'm going to stop this video, and I'm going to create a new video going over the linear combinations.